All right. This second part is on logarithms and how to graph it. And notice how here we just have an extra table. And with this extra table, I'm going to make reference points for 3 to the x because my problem has log base 3. The reason why is because we know that logarithms and exponential functions are inverses of each other. So once I make my table of values for 3 to the x, I can switch my x and y values so that I get my reference points for log base 3. Now I'm going to look at my transformations. I could see that I have right 2 units, and then I can see that I have down 2 units. So right 2, down 2. Remember that right 2 represents your x value, so I'm going to add 2. And then for my y values, I'm going to go down 2 to get these values right here. I'm going to plot them, but before I plot them, let me look at my asymptote. Notice how with your asymptote, your argument can't be 0. So in this case, my asymptote is at 2. X is equal to 2. I have 2 and 1/3, -3. So say like that thing right here. I have 3, -2. I have 5, -1. And then I have 11, 0, which is right here. Graph it. And it should look something like that right here. Your domain is 2 to infinity because of your lovely restriction at 2. And then your range is at -infinity to +infinity. Likewise, for number 5, you're going to do the same thing. Nothing special here. You have log base 2, so your reference points are going to be 2 to the x. Once you do that, flip x and y. And then you have a vertical stretch of 3, right 5. A vertical stretch of 3, remember, affects your y value. So I'm multiplying my y values by 3. Once I do that, I am going right 5, so that affects my x values. Right 5. And this gives me my lovely points for y is equal to 3 times log base 2, x minus 5. My domain is going to be from 5 to infinity because my argument can't be anything less than 5. My range, -infinity to +infinity. And your asymptote, based off of my restriction, is at 5. (5.5) and -3. 6, 0. 7, 3. And 9, 6. Graph it, and then call it a day. On the test, you are going to be expected to give me at least 3 points. So these would be good. Number 6, I want you to try this on your own. Pause the video, try it by yourself, and then play it with my explanation. Okay, so you have negative log base 4 x plus 6 plus 1, meaning that your reference points have to deal with 4 to the x. Oop, that should not be 0, that should be 1. Looking at your transformations, you have a reflection across the x-axis, you have left 6, and then you have up 1. Since you have a reflection across the x-axis, remember that affects your y value. Since it affects your y value, I know that my new y has to be 1, 0, -1, -2. I'm going to go left 6, so this is going to give me 1/4 minus 6, which is about 5.75. Well, negative 5.75. 1 minus 6 is -5. 4 minus 6 is -2. 60 minus 6 is 10. And then up 1. So that's going to give me 2, 1, 0, -1. So I have a domain of -6 to infinity. My range obviously is going to be -infinity to +infinity. And then my asymptote is at -6. Okay. I have -5.75, 2. I have -5, 1. I have -2, 0. And then I have 10, -1. Now, since it is a reflection across the x-axis, it does make sense that your graph looks something like this right here. All right, on Delta Math, you have 8 problems regarding logarithms and exponential functions and how to graph them. If you know how to graph these 6 problems, then you should be able to do the Delta Math problems, and you should be able to do whatever is on the FRQ.